Okay, hello everyone.
PC disconnected.
What? Sorry. My name is Chiara Lombardo. I work for CNIT and we are members of the Spider project. The goal of the Spider project is the delivery of a cyber range in a way that is extensive and replicable. And the main target is offer cybersecurity emulation for 5G in terms of training and also to the goal of investment decision support. The Spider platform features integrated tools for cyber testing, which also include emulation tools, learning training methods, and also real-time econometric models. The Spider project supports both self-paced and team-based exercises on the Spider platform and allows more than one stakeholder at a time to rely on the same platform in a secure and isolated fashion. And today we're introducing some of the features that are a part of this platform that allow these secure and isolated operations on the platform. So this is the general architecture of the project. I have highlighted with the red box the OSS, which is the module which provides the features that we're presenting today. And it represents, in a simplified way, we can say that it represents the networking part of the Spider architecture between the application, the vertical application orchestrator, and the actual executable service graph on which the red team, blue team member exercises, the attack and defense operations on the cyber range take place. So this is an overview of the NFV platform of Spider. You can see the red circles around the two features that we will demonstrate today. So basically, in this platform, we work above and below OSM in order to terraform the physical part of the network and at the same time onboard them on open source MANO in terms of a virtual topology, which allows viewing the network in an abstracted fashion so that players can perform their exercises on the platform without having the requirement of the actual knowledge of the physical components underneath. The first part of this presentation / demonstration will focus on the Testbed Manager, which is the block that here is bottom left in the red circle. The Testbed Manager has been designed to manage the available physical computing and network components. We do this with a graphical user interface that is linked to all the software tools active in the system. So, for example, here we've got OpenStack, Kubernetes, MAS, and I'll show you in a moment how all these software tools are accessed via the graphical user interface of the Testbed Manager to have all these tools in a one place. The Testbed Manager provides the users with a safe and isolated working environments and also allows them for the automatical setup of the platform for each exercise and also allows to restore to refresh the configuration once an exercise is finished. We've got the starting configuration of the exercises saved in a form that includes also the configuration of the OpenStack networks and routers and the virtual machines required for the exercise itself. And I'm showing you, going straight to the graphical user interface now to show how by relying on a metal as a service paradigm, we can initialize, configure the network and refresh it to give it as a brand new platform for each exercise. So now I'm switching to my browser. Please let me know if you can see still my screen. Okay. Okay, so this is the graphical user interface of the Testbed Manager. I'm basically focusing on 3 types of objects: administrative domains, projects, and OpenStack instances, and I'm showing them one at a time to you. Now, at the moment, we've got only one administrative domain, which is our testbed, the physical testbed located in Genoa, Italy. For the moment, it is just one, but we expect in the future to be able to manage more than one testbed at a time. So imagine here a list of testbeds geographically distributed, for example, across Europe, and all managed with the same interface. So from here, we can see that we have a MaaS server, Metal as a Service, that reports all the physical machines, the controllers, the images, the virtual machines that exist in the testbed. At the same time, the available network devices, which are the main switches, routers, and the firewall managing the access to the testbed, are also available from here, as well as the virtual private networks with the configuration to be provided, for example, to the users. And we also have the list of physical network functions available in the platform. So we've got these first 2 are emulators for 5G cores, and the third one is an emulator for user equipment. There's also the possibility to change the configuration of this administrative domain by changing the parameters for each feature available in the testbed. Now, moving on to the project, the term project in this case represents the isolated spaces that we provide to different environments leveraging on our platform. So, for example, here for Spider, we've got all the details of the project, the possibility to apply changes, or, for example, here we've got only one OpenStack instance associated to the project, but it's possible to deploy further instances. I'm trying to go a little bit faster now because I see time is sticking out. The deployment of a new instance regards the assignment to one of the projects I showed before, and also the selection of the control, network, compute nodes among the ones available in the testbed that I showed you before on Metal as a Service. Finally, the individual OpenStack instances, again, from here, we're linked to OpenStack to see all the details about the individual instance. And here is there's also a possibility of modifying, handling the instances, the nodes of the instance, and the individual resources in terms of networks, routers, and images. Here, there's also the most relevant feature for the Spider project, in the sense that in order to provide a new refreshed testbed every time an exercise is finished, it's possible to, I'm not going to do it now because it takes quite a long time, it's possible to reinstall the instance, starting from a configuration that includes the elements I mentioned before. And so can a following user can start from scratch again with its exercise. If I'm not forget anything, I'm moving back to the slides to proceed with the second part of the presentation / demonstration. Do you have any questions so far? Okay, take it as a no. Moving back to the presentation. So, Roberto, please go ahead.
Okay, so good morning to everybody. Just few words on, excuse me.
I'm muting myself, yes.
Yeah, okay. Okay, thank you, Chiara. Just a couple of words regarding the NFVcl. We already presented a preliminary version of the NFVcl realized in the Matilda project some years ago in an event like this. So what is the NFVcl? It's a part of a NFV aware, 5G aware OSS that is attaching to OSM to extend and to augment some of the functionalities. It's working on the concept of blueprints. So what are blueprints? In rough words, are a set of coordinated network services that we are managing through OSM. Just to give you an example, in this picture, this is an old picture because it's representing a 4G network in an EPC. A blueprint could be, for example, a radio mobile network, a 5G network, or a 5G plus a 4G network. And internally, it's organized in a number of different services that are managed all together in order to keep the configuration of all the VNFs, PNFs, KNFs that are composing such blueprint coordinated with a similar configuration. So please go ahead, next slide. Yeah, go ahead, it's only written, let's use only the image. So for doing this, every blueprint exposes a number of methods of functionalities. The first one, the mandatory one, is the one that we are using for initializing a blueprint. So for initializing what? The number of NSD that, depending on the input configuration that we are passing, will build a certain number of network services. And therefore, we will have a day zero in which we will select which is the best blueprint that we can use for our purposes, which is the best implementation. We will retrieve the physical deployment units that are needed, and then we will build the descriptors that are needed. We are currently building not only the network service descriptors, but even the VNF descriptors that we are uploading dynamically, blueprint per blueprint, onto OSM. Then we pass to day one. We will initialize blueprints with a partial configuration of the services in many cases, because some configuration parameter might depend on other data that are acquired during installation processes, like some IP addresses or something like that, that should be placed within the configuration of every VNF. Then we pass to the day two. In the day two, the blueprint uses some what we are calling VNF configurator. They are simply Python modules. We have one for each type of VNF that we onboarded into the OSS. And there we are just producing the commands, the list of commands and the list of configuration files that we need in order to configure that VNF. Then at this point, okay, if we have a KNF, in the reality, we don't need a VNF manager because with the latest integration of Elm in OSM, there is no need for this. But in all the other cases, we are using a special VNF manager that we designed. It can run both on top of Juju and Helm, and it's a sort of Ansible proxy. So practically, when the VNF manager has been made running, it downloads the Ansible playbook file from the NFVcl, all the configuration files produced by the NFVcl, and apply them to every VNF. So I think that we can switch to the real demo. So I'm trying to share very quickly, just to give you an idea, my screen, this one. Okay, I hope that you can see what I'm showing. On the left side, we have an alpha version of the web interface of the NFVcl. Here we have a console where the NFVcl is working, and here we have just the web interface of OSM. So what I would like to do is to show to you that the topology that is produced by the MetalCL, by our Testbed Manager, is onboarded here. So the MetalCL is able to onboard to us the topology. So we have the OpenStack instances, we have networks, we have PDUs that are exposed by the MetalCL. And we can also modify this logical topology by adding, I don't know, some networks in OpenStack, and we can do similar things. So regarding the blueprints here, we have 3 blueprints that are already deployed. The first one is a blueprint that we developed, a further blueprint that is instantiating a Kubernetes cluster. It's different from the one that is in the documentation of OSM. Here, the blueprints allow us, for example, to add some worker into some OpenStack instances close to some geographical area. We can onboard this into OSM as Kubernetes cluster where to deploy to deploy VNF, KNF. We can tell some of the workers and so on. So let me pass back. We have already a blueprint running a 5G core and a URL SIM, an emulator of a Gnode B plus 1 UE. Let's just declare a new 5G core. Here we have to decide the PLMN, on which network we would like to use as control network, on which one to map the first DNN, which one to use as wide area control to speak with the base station. We can add several options on the configuration of the 5G core. Here we have to select the VIMs that we would like to use in the case that we want to do a multi-domain deployment. And we have to select just one VIM to, let me say, where to place the control part of the network. Then here, adding a tracking area code means adding a radio access network. So 24 is the TAC associated to the emulated base station by URL SIM. Then we have just to submit. At this point, the operation is in progress. We can see from the list of the blueprints that here it's running. You see that here now we have some new function that have been onboarded. Also in the packages, we can see that we have packages with the identifier of the blueprint because they are created dynamically according to the need of the specific blueprint. And that's the same also for network service packages. I'm awaiting, but we are out of time. Here you can see the page of the function when it will be deployed, completely deployed with day 2 operation. We will see here also the configuration of the core, but on the shell of the NFVcl, you can see here, I'm moving this part, that we are still awaiting for the configuration. But I think that at this point, we show most of the functionalities and you were able to understand what both NFVcl and one is running, configured, that's the 5G core. The MetalCL and the NFVcl are doing. The first one built the scenario from the bottom, the topology, the virtual topology, and then the other act like an OSS consuming all the functionalities exposed by OSM. I think that we can stop here.
Okay, I think we have a few minutes for questions. We have questions for Chiara and Roberto.
Mm-hmm.
All right, so for this, you're just using one single OSM to manage all of it, or is the OSM subdivided at all?
One instance of the NFVcl is using one OSM, but it's quite easy to also to use multiple OSM for our purposes. But it's something that we prepared in the code, but still we didn't find the let me say the key use case in order to have multiple OSM in the bottom of the NFVcl.
Yeah, no, that's fair. It's doesn't necessarily make sense to have multiple OSMs, but the reason I was wondering was what you did for user or tenants and segregation in the OSM, such that not everybody sees all of the everybody else's work in OSM.
Oh yeah, this is natively possible. I think that the NFVcl is a tool for an OSM tenant, let me say.
Okay.
So that's a tool for simplifying the onboarding and let me say the management of the life cycle of multiple services, especially for complex networks, let me say, because one blueprint is containing the code for doing that work. And we think that this might happen within the NFVcl and not with the upper part of the OSS, only within the same network platform tenant, so the same OSM tenant.
Okay, very nice.
Thank you very much. If you have any other questions,
Okay, thank you very much.
Sorry, this is more just a quick sort of hypothetical question, and that is, so I see that you're using MAS, and right now OSM doesn't do any sort of bare metal provisioning or anything like that. Would you be interested in seeing OSM try and do life cycle of bare metal servers, the way MAS does, or layer on top of it, or Ironic, or any of the other sort of bare metal management systems out there?
Yeah, I think that somehow playing with MAS and with the control of bare metal resources somehow led us to think, let me say, that there is something more in the middle of between a PDU and a VDU or a KDU. So probably there is something there to be expanded, but yeah, that's possible on one side. It would be very interesting to do this, but on the other side, we have to think about the dependencies, because one of the things that I didn't set due to the time mostly is that we are starting to expose even a single service or even a single function in different way in different blueprints. For example, you run SIM run you are on same software within virtual machines. Okay, so that's an IaaS service. But when this is used by the blueprint that is realizing the 5G core, it becomes a PNF because it can be only configured. We are losing the control of the life cycle, so we can only push configuration. Well, I think that if you focus on the bare metal control, the situation would be quite similar. So on one side, you have the control. You can manage the life cycle, but then on the other side, it will be locked to something, just like a PDU. So that's something that the standard reflects, but it can be interpreted into various fashion, let me say. I don't know if I was able to pass my idea.
No, I'm just thinking, I mean, sorry, yes, you were able to, and it was just more of a thought for OSM future directions and whatnot. If, you know, if we're starting to see a need for orchestrating bare metal, and I mean, this is an example of such a use case. So thank you very much for that.
Yeah, in any case, it will be a part of the future, I hope.
Indeed. Thanks.
Thank you.